Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to keep talking about my current project of coding the combat system for a viewer's game. In particular, I've coded the attack roll that the system makes when a player character is attacking an enemy. So as you can see, I've set up a combat here. We have the enemy at distance 3 because they actually got the initiative and they moved 2 spaces towards the player character. I have the option to shoot. So I'm going to choose the one target that there is. And it tells me that I roll a 5 and a 6 plus my sneaky score of 2 minus the target's sneaky score of 2 for a total of 11. So let's check those numbers. Do they add up? 5 and 6 is 11, plus 2 is 13, and minus 2 is back to 11. So that makes sense. And then it says long success. Well, that's what it should be because 10 or more is a long success. If we look at the sneaky score, this character has a moderate... There it is. This character has a moderate sneaky score, which numerically is 2. So that is correct. And the target's sneaky score, well, this is a female giant mosquito, and female giant mosquitoes do indeed have a sneaky score of 2. So all of the numbers are working. We can see there that it's, because I've zipped back and forth, it's done the roll again. So we have a different set of numbers, but once again, they add up. So as you can see, we haven't done the consequences of the roll yet. We're just doing the roll itself and determining whether it's a success or a failure. But let's have a look at the code. So this is all going to take place in the PC side attacks passage. This is a passage that I showed you in the last video, but it only had comments in it. We didn't have any code yet, so I've now done the code. There aren't any new variables, but I'll go back to initialize to tell you how variables work if we need to do that. So let's have a look. Now, this is going to work very similarly to enemy strikes because there's sort of a universal mechanism in the game, which is roll 2 dice, roll 2d6, and add the relevant attribute, and then 7 is a success and 10 is a long success, and 2 or 3 or less is a long failure. In fact, that's used if you were to roll to see if you were charismatic enough to convince somebody to do something for you, for example. That would be the same, except you'd add your sexy score instead. And so monsters attacking the player characters and player characters attacking the monsters works in pretty much exactly the same way. I have done 2 separate pages rather than having a single one, just because I think it's easier to demonstrate and explain what's going on and to follow what's going on if you have 2. But you might notice that I've called it PC side attacks, not player character attacks. And that's because I intend to use this same passage for the companion attacking the enemies. Those 2 are similar enough that I decided to put them together, but then I decided to have the enemy as a separate passage. Although I could have had them as one, or I could have had 3 separate ones if I wanted to. But, you know, I mean, all of those options would work. I just think this is probably the best compromise between sort of making it efficient code and making it easy to see what's going on. So let's have a look. This is what we had before. We had the target, just reminding us that Z is the number of the target. X is a text, which gives us the name of the weapon, a space, and a number. And the reason we do that is because that's what a particular weapon array uses to index its slots instead of numbers. So we start by rolling. We did have another one in there, and I said that that one might not be needed in this, but and it turned out, yeah, it wasn't. So I've scrubbed out that part of the note. So first of all, the system simulates rolling 2 normal 6-sided dice and puts the values in Z2 and Y2. We simulate rolling a dice with random bracket 1, 6 end bracket. Then we find out which attribute is added to the attack roll, and that depends on the maximum range of the attack that we are choosing to use. And it's the maximum range, not necessarily the range at which the attack takes place. So you might be shooting, which is a long range attack, but you might be shooting someone who's in the same space as you, and so therefore it's at very close range. But the relevant thing is the maximum range. All shooting attacks use a particular attribute. They use sneaky. To use the other attribute which is used, which is the strong attribute, you'd have to use an attack which can only be used at close range. So in the case of a pistol, you could shoot, which is long range, or pistol whip, which is close range, and using pistol whip would use the strong attribute. If it's at mid range, that's the same as long range. And I just noticed a little mistake there, which I will fix in the version I upload. I've got two greater thans. So we say if WEA underscore ATT X, which is that text there, 1 is equal to 0. That slot is where we put the range. It's 0, 1, or 2. If it's 0, then we set X2 equal to 1, which is the strong attribute. Otherwise, we set it to 3, which is the sneaky attribute. Now, that's not how I did it for the monsters. I have, in the attacks array, I have what attribute is added to the roll, and then I have range. And I think that is inefficient, because we can get what attribute is added to the roll from the range. So I think I will change the way that's set up. But that is for a future video. What I've done there works. It's just sort of a bit redundant. So we have the attribute, and then we need to decide, okay, we know whether we're using strong or sneaky. Well, now we need to get the value of strong or sneaky, and that's what we do here. We look at INI underscore who, which is who is currently acting, who currently has the initiative. If it's 0, which is the player character, then we set W2 equal to ATT underscore PER, $PER, $X2. Well, $X2 is which attribute? $PER is short for persona, and it's what persona, which is basically character class or character type, the player character is using. And $ATTPER is an array that has among other things, the attributes of the different personas. Because in this game, if you are a warrior, for example, you always have all warriors have the same attributes, all scoundrels have the same attributes, and so on. If INI underscore who does not equal 0, then the only other way we can get to this page, well, we can't do that yet, but we will be able to get to this page if it's a companion attacking. And so that uses exactly the same code, except for instead of $PER, we use $com INI underscore who 1, because that's where we store the persona of companions. Then we get the target's sneaky score, because that doesn't change. It's always the target's sneaky score to simulate their ability to sort of dodge and fake out and whatever. And we use enemy underscore ATT enemy Z1. That's the first slot, because that is the enemy's type. And then 3, because 3 is where we store the sneaky score, just as we store just as we store it in ATT_PER, we store sneaky in 3. We do the same thing with the enemies. Then we add that all up. We set y3 equal to z2 plus y2 plus w2 minus z3. So it's the 2 dice rolls plus the relevant attribute minus the target's sneaky score. Then we print the result. We say player character or companion 1 or companion 2 rolls 3 and 4, for example, plus their strong score of 2 or their sneaky score of 0 or whatever it might be, minus the target's sneaky score of 1 or 2 or whatever, for a total of whatever the total is. And then we have this branching. And of course there needs to be more code, and there will be more code coming up soon for all of these, but at the moment it's just telling us what we've got. So if that total is less than 4, it's a long failure. If it's less than 7, it's a failure. If it's less than 10, it's a success. And otherwise, which will be if it's 10 or more, it's a long success. And that is how the player character attacks. That is how the companions will attack once I code that. It's very similar to the enemy attacking, except that we draw the data obviously from different arrays, from different variables, different places. So what I'm going to do next is the consequences of those attacks, doing damage or the results of a long failure for the player character, and so on. I might also fix that little redundancy with the enemies, but if I do that, I'll certainly do this as well. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.